Hello students, let's start with an interesting question. Have you ever tried to solve an equation where the variable is squared, like height and area problems, or those tricky physics questions about the path of a thrown ball? All of these led us to an important concept in algebra, quadratic equations. A quadratic equation is one where the highest power of the variable, usually x, is 2. The general form is ax²+bx+c equals 0, where a, b, and c are real numbers and a is not equal to 0. For example, 2x² plus x minus 300 equals 0 is a valid quadratic equation. Notice the x² term. That's what makes it quadratic. Quadratics appear when we deal with parabolas, area calculations, or even projectile motion. So yes, they're more than just algebra, they help explain the world around us. Now that we know what a quadratic equation is, how do we recognize one in action? Let's look at a few examples. The equation 2x² minus 3x plus 1 equals 0 fits the standard format. It has x², x, and a constant. What about this one? 4x minus 3x² plus 2 equals 0. Even though the x² term comes second, we can rearrange it. Write it as minus 3x² plus 4x plus 2 equals 0, and yes, it's still quadratic. Or take 1 minus x² plus 300 equals 0. Rearranged, it's minus x² plus 301 equals 0. Again, the x² term tells us it's a quadratic. So the key is simple. If it has an x² term and the coefficient of x² is not 0, it's quadratic even if the terms are out of order. Let's dig a bit deeper into the formal structure of quadratic equations. Any equation of the form p of x equals 0, where p of x is a polynomial of degree 2, is a quadratic equation. To make things easier to work with, we often express the equation in what we call the standard form, that is, ax² plus bx plus c equals 0, where a is not equal to 0. For example, if we take x² plus 5x plus 6 equals 0, it's already in standard form. We have a equals 1, b equals 5, and c equals 6. Why is standard form important? Because most solution techniques, like factorization, completing the square, or the quadratic formula, are based on this arrangement. Quadratic equations are not just a topic in your math book, they're everywhere. In physics, when we calculate the motion of an object that's thrown upward, we use a quadratic equation to find its maximum height or time of flight. In geometry, if the area of a rectangle is expressed in terms of a variable and we are asked to find its dimensions, the equation we solve is often quadratic. In economics or business math, finding the maximum profit or minimum cost sometimes comes down to solving, you guessed it, a quadratic. So whether it's launching a rocket, fencing a garden, or calculating investment returns, quadratic equations are essential tools. Let's apply what we've learned with some quick checks. Look at 5x² minus 7x plus 2 equals 0. Is it quadratic? Absolutely, because it has the x² term and fits the standard format. Now take 3x plus 9 equals 0, no x², so this one is linear. Here's a tricky one, x into x minus 4 plus 3 equals 0. Expand it and you get x² minus 4x plus 3 equals 0. And yes, that is a quadratic equation. So always check for the degree. If the highest exponent of the variable is 2, and the equation can be written in the form ax² plus bx plus c equals 0, then you've got yourself a quadratic equation. Let's quickly revise what we've learned about quadratic equations. A quadratic equation is any equation that can be written in the form ax² plus bx plus c equals 0 where a is not equal to 0. We practiced recognizing them even when they don't appear in standard form. We saw examples, rewrote equations, and even connected them to real-life scenarios in science and economics. Understanding what makes an equation quadratic is the foundation for learning how to solve them, which is exactly what we'll explore next. In the next video, we discuss the solution of a quadratic equation by factorization. See you there.